Alright, so in this question we have to use the basic concepts of the pH equation and the hydrogen ion concentration, as well as some part of the Nernst equation. So the question that we are given here is the pH of the solution in the cell that is given with hydrogen and AgCl electrodes is 0.65. Now what we have to do is calculate the EMF of the cell. E naught Cl AgCl is equal to 0.224 volt that is given to us. So we have to calculate the EMF. So Tushar, please take us through the solution.
The question, in the question the pH is given. So from pH, a concentration of H ions can be determined.
Right.
And as well, and for the electrode potential, one of the half cells electrode potential is given, and for the other half cell we can see that is standard hydrogen electrode. So we know electrode potential for that, which is taken as reference, to be 0.
Yeah.
So hence E cell can be calculated from these data using the Nernst equation.
Alright. So just we can start with the pH equation, I guess.
So like first we'll write the half reaction for this.
Alright.
This is half H2 gives H plus electron. This is the oxidation of hydrogen.
Yeah.
And for this we know E standard is equals to 0 volt.
Yeah, we take this as the standard.
For the second half reaction, it's AgCl plus electron gives Cl negative plus Ag, and for this it is given as 0.224. So from here we can write the full reaction, which is AgCl plus half H2. These electrons would be cancelled.
Yeah.
And this gives H plus Cl negative. This is the HCl in the ionic form.
Yeah.
Plus Ag.
Alright.
Now the electrode potential for this whole reaction is the sum of electrode potential of these two.
Yeah. Oxidation and reduction.
Oxidation and reduction. And hence E naught here is 0.224 volt.
Alright.
Now we'll calculate Q, that is the quotient ratio for the reaction, which is H plus into Cl negative. This is because we have taken HCl. Now we know for HCl there are equal number of moles for H and Cl.
Yeah.
Hence we can write this as square of concentration of hydrogen.
Yeah.
Now pH is given to us, and it is given as 0.65.
Yeah.
From ionic equilibrium we have studied that pH is equals to 10 to the pH is equals to minus log of concentration of H ions, and this is a very important formula which would be used for the question. So from this formula we can calculate the value of H ion concentration.
Yeah.
Here H ion concentration from this equation can be written as 10 to the power minus pH, and pH is given as 0.65.
Yeah.
So this is the H ion concentration from this equals to 0.2239.
Yeah.
Now we can square this to get the value of Q.
Yeah. Q is H plus square as we had derived earlier.
0.2239 whole square, which gives us 0.05.
Alright.
Now we need to calculate electrode potential of the cell, and to calculate the electrode potential we know the Nernst equation gives us the relation between the electrode potential and the quotient ratio and the standard electrode potential. Hence we'll use the Nernst equation here. So E cell is equals to E naught minus 0.0591 by N log Q. Now this is the very important equation which would be used, as I told you in the beginning, and we'll use it here too. So we have calculated the value of E naught.
Yeah, this is a Nernst equation, as you would remember from theory.
We have calculated the value of E naught. We have calculated the value of Q.
Yeah.
And from the first equation, from these two half reactions, we can directly see that here is 1 electron used.
Yeah.
Hence N is equals to 1.
Yeah.
So by putting the values of E naught as 0.22 volt minus 0.0591 by N, which is 1, log of Q, and Q here is 0.05. So we can calculate this and we'll get the value as 0.299 volt.
Right. So just put the values in this equation, just check the answer once. So it's pretty straightforward using the pH equation and the Nernst equation to arrive at this answer. Alright, so then move on to the next question. Alright, so in this question, we will use that equation that we had studied earlier in theory, which combines the concepts of the two laws of Faraday and use the concept of efficiency that you should know to find out the answers that are required. So the question that we have been given here is that a solution of copper sulfate is electrolyzed between copper electrodes by a current of 16 ampere with 62.5% efficiency for an hour. Now we have to find out what changes occur at the electrodes and in the solution. So Tushar, please take us through this question.
Okay. So first we'll write what happens at anode and at cathode.
Yeah.
So at anode, copper would be oxidized to Cu2 plus plus 2 electrons, whereas as at cathode, Cu2 plus 2 will combine with 2 electrons and it would result in solid copper.
Correct. Alright.
So here we have to calculate what changes occur at electrodes in the solution.
Right.
So for this we'll use the combined equation for the Faraday's laws, that is W by M equals to Q by NF.
Yeah, if you don't remember this, you can just skip back to the theory part and check this out.
This is very important and a very easy way to remember both Faraday's laws. But Q is not given directly here. It is written that the efficiency of the process is 62.5%.
Correct.
Hence, the Q would not be the 100% as we take it always. So, the calculating formula for Q is IT, that is current into time.
Right.
But here it is 62.5% of the whole. So, we'll take the 62.5% of I into T.
Yeah.
I is given as 16 and T is given as 1 hour. So we'll directly convert this into seconds. It would be 60 minutes into a minute consists of 60 seconds.
Yeah. So here only 62.5% of the current is being used, the energy. So yeah, we have to take 62.5% of that.
Hence we can call this as Q effective.
Alright.
Now N for the process is 2.
Yeah, 2 electrons.
As 2 electrons being exchanged.
Right.
Now we know the value of F, which is 96500.
Yeah.
Now we have calculated we know the value of F, N, Q. We need to find W. But what about the value of M? Usually the value of M would be given in the question, but still it's better to remember the molar mass of few elements like copper and zinc.
Right.
So the molar mass of copper would be 63.5, and if you can't remember this, no problem, it would be mostly provided in the question.
Yeah.
So now we can calculate the value of W.
Alright.
And W is equals to Q by NF into M from the above equation.
Yeah.
And we know the value of each and every quantity here.
Yeah.
Hence, when we'll put the values of all the quantities, we'll get 11.811 grams.
Yeah. Just put the values in the equations and check the answer.
So we have calculated the mass, that is the value of W.
That is the mass deposited on
So,
the electrodes. Yeah.
This means that 11.811 grams of copper is dissolved from anode and 11.811 grams of copper is deposited on cathode.
Right.
Hence the original concentration of the solution remains same.
Yeah. All right. So the concentration remains the same, and we got how much mass is deposited as well from this equation. All right. So we'll move on to the next question. Alright, so in this question we have to calculate the Gibbs free energy and delta S as well for a particular cell reaction, and we have to use some basic concepts in thermodynamics which we had studied earlier for that. So basically the question states that we have to calculate delta G0 and delta S0 at 298 Kelvin for the given fuel cell reaction, which is 2H2 plus O2 gives 2H2O, and the E naught of the cell is given, and the delta HF naught for H2O is also given in the reaction in the question itself. So Tushar, please take us through this question.
Okay. We know that delta G is equals to minus NFE. Delta G naught to be precise, because it's at 298 Kelvin, which is the standard one. Hence delta G naught is equals to NF E naught cell.
Right.
And we also know that N, which is number of electron exchange. Oh, here it would be a bit complicated to calculate that, because here we can't see the electrons directly.
Yeah.
But that's not a big problem. This is very common in such questions. We can directly pick one of the atoms like oxygen. Here the oxidation state of oxygen is 0.
Yeah.
Whereas here it is minus 2.
Correct.
So number of electron exchange would be 2 into 2, because this is not a single mole, it is 2 moles. Hence the value of N would be 4.
Correct. So we can get the N factor from the oxidation states at the beginning and at the end. Alright.
So we get the value of N, we know the value of F, and whereas E cell is directly given in the question,
Yeah.
which is here.
Yeah.
So from this we can calculate the value of delta G naught, which is minus 4 into F, which we know the value of F, and it is E naught cell, which is 1.23.
Yeah.
So this gives us minus 474.78 kilojoules.
Yeah.
Now in the question we need to calculate the value of delta G, which we have done it here.
Yeah. It's very easy. Just put the value in that very familiar equation and we get the value of delta G0. Now for the next part.
Now we need to calculate the value of delta S.
Yeah.
And अब ये वैल्यू हमें वहाँ से क्या नाउ अब ये वैल्यू हमें एक थर्मोडायनेमिक्स की इक्वेशन यूज़ करनी पड़ेगी. इलेक्ट्रोकेमिस्ट्री एक ऐसा चैप्टर है जिसमें आयनिक इक्विलिब्रियम, केमिकल इक्विलिब्रियम, थर्मोडायनेमिक्स की चीज़ें यूज़ होती रहेंगी, तो वो चीज़ें काफ़ी इंपॉर्टेंट है.
Yeah. So if you have forgotten them, just brush up your concepts.
ये सब 11th में हमने पढ़ा होगा. You just need to revise those. So we'll use the equation delta G is equals to delta H minus T delta S.
Yeah.
This would be standard, so we have to put knots. Delta G naught, delta H naught, delta S naught. From this equation we can write that delta S naught is equals to delta G naught minus delta H naught by minus T.
Yeah.
We know that it is at 298 Kelvin, so the value of T would be 298. Delta, we have just calculated the value of delta G. Now we need to calculate the value of delta H. अब यही वो पॉइंट है जहाँ पे सबसे ज़्यादा बच्चे गलतियाँ करने वाले हैं, बिकॉज डेल्टा एच वैसे तो हमें क्वेश्चन में डायरेक्टली दिया हुआ है.
Yeah.
लेकिन हमें इस बात का ध्यान देना है कि यहाँ पे 2 मोल्स कंज्यूम हुए हैं.
Correct.
Delta H is only for the single mole.
Huh.
Hence, the value of delta H naught would be twice of that. That is 2 into minus 285.8.
Yeah.
So now we have the value of delta H, T, and we have just calculated the value of delta G. So from this we can calculate the value of delta S not by putting the values in this equation.
Yeah.
By putting those values directly, we get minus 234.9 joules per Kelvin.
Yeah, fine. So the answer is minus 324.9 joule per Kelvin. So one thing you have to keep in mind is that the delta H naught that is given is for each mole, like for 1 mole. So you have to keep in mind the number of moles of the reaction, number of moles involved in the reaction, and multiply that correspondingly with that value in order to get the correct answer. Alright, so we come to the end of this question. We'll move on to the next one. Alright, so in this question we have to use the concepts of the Nernst equation as well as the principle of the spontaneity of the reaction based on whether delta G0 is negative or positive. So the question that is given to us is, if Zn2 plus is maintained at 1 molar concentration, what is the minimum copper 2 plus concentration for which the reaction that is given, Zn plus Cu2 plus gives Cu plus Zn2 plus, is still spontaneous in the forward direction, that is in the direction that is given. So Tushar, please take us through this question.
ओके अब हमें सबसे सीधी बात देख रहे हैं यहाँ पे, अगर स्पॉन्टिनिटी वर्ड है, स्पॉन्टिनियस वर्ड है, तो हम सबसे पहले दिमाग में जो चीज़ आनी चाहिए वो है डेल्टा जी.
राइट.
ओके, so delta G value is negative for a spontaneous reaction.
Yeah, as we had studied earlier in theory.
And we know that delta G is equals to minus NFE.
Correct.
So if delta G would be negative and we have a negative sign here, hence we can say that the value of E should be positive for a spontaneous reaction.
Correct. Since N and F are obviously positive quantities.
Hence the value of E should be positive. Okay, so as it is given that from the given reaction, it's Cu2 plus Zn, it gives us Cu plus Zn2 plus.
Right.
Okay, so quotient ratio from this equation can be written as Zn2 plus concentration by Cu2 plus concentration.
Yeah, this is the ionic ratio. Yeah.
Now we need to find the minimum concentration of Cu, and the concentration of Zn2 plus is given that it is maintained at 1 molar.
Yeah.
So we can assume the concentration of Cu as X for the time.
Yeah. All right.
Okay. Now we need to calculate the E cell, that is electrode potential, and the Q is involved here. Hence the first thing that should come to our mind is the Nernst equation.
Right.
So from Nernst equation we can write E cell is equals to E naught minus 0.0591 by N log Q.
Right.
Okay, so we know the Q value, and E naught is given in the reaction, like that's not a problem, like we'll see that. Okay, so for the Q value we know it is 1 by X.
Yeah.
And
E naught is not mentioned in the question, but we'll get to it soon enough. Alright.
E naught for this reaction is like, it should be given in the question usually. So it should be the E naught should for the cell reaction is 1.10 volt. It's missing right now, but it would be provided, so you don't need to take tension for the such part things.
Alright.
So E naught is 1.10 minus 0.0591. Now N, we can directly see it's plus 2 here, and the oxidation state for copper is 0 here.
Yeah.
Hence we can see that there is difference of 2.
Yeah, so N is equal to 2 in this case.
Hence N is equals to 2 here. It's log 1 by X.
Correct.
Now this is the E cell, that is electrode potential of cell.
Yeah.
And for this to be spontaneous, E should be positive.
Yeah.
Hence we can write it is 0.0591 by n, that is 2 here, log 1 by x should be less than 1.10.
Yeah.
Now we just need to solve this equation to find the value of x.
Yeah.
Hence from this x would come as, x would be more than 5.95 into 10 to the power minus 38 m. Hence x is more than this. This is the minimum concentration.
Right. So you can just check for when the value becomes greater than 0, and then at that minimum concentration the reaction will become spontaneous in the forward direction. And you can just put the values in this equation and check the results for yourself. So yeah, that's all there is to this question. We'll move on to the next one. Alright, so now we move on to question number 8. Here, this is a graph-based question. So we have to draw the graph and compare it with the Nernst equation and derive at the corresponding results. So the question that we are given here is the graph between E naught of the cell and log of the ratio of Zn2 plus and Cu2 plus is linear with an intercept on E cell axis of 1.10 volt. Now what we have to do is we have to calculate the E cell for the given reaction. Zn plus Cu2 plus gives Cu plus Zn2 plus for the Zn2 plus concentration of 0.1 molar and the Cu2 plus concentration of 0.01 molar. So Tushar, please take us through this question.
Okay. अब ऐसे क्वेश्चंस में जिसमें ग्राफ दिया हुआ है उसमें हमें डायरेक्टली एक रफ प्लॉट बना लेना चाहिए.
Right, to get a better idea of the question. Yeah.
So इसमें हम एक रफ ग्राफ बनाएंगे. यहाँ पे हम ई सेल लेंगे एंड इस जगह लॉग ऑफ Zn2 प्लस स्लैश Cu2 प्लस, ये हमें डायरेक्टली क्वेश्चन में दिया ही हुआ है, तो हमने अब तक कुछ खास नहीं किया. अब क्वेश्चन में बताया हुआ है कि ये ग्राफ लीनियर है और ये इसका इंटरसेप्ट है विच इज गिवन एज ई सेल.
राइट.
और इसकी वैल्यू हमें दी हुई है 1.10 वोल्ट.
करेक्ट.
ओके. अब हमें लॉग ऑफ Zn2 प्लस बाई Cu2 प्लस दिया हुआ है और रिएक्शन से हम सीधा कह सकते हैं कि दिस इज इक्वल्स टू Q, तो सो दिस इज लॉग Q. अब जब हमें यहाँ पता है कि ये स्ट्रेट लाइन है तो हम स्ट्रेट लाइन की इक्वेशन हमें पता है, दैट इज y इक्वल्स टू c माइनस mx. और यहाँ पे जब log Q और E सेल दिया हुआ है तो हमें सीधा सबसे पहले जो याद आएगा वो है नर्स्ट इक्वेशन. सो विल जस्ट राइट द नर्स्ट इक्वेशन बिलो दिस. सो E इक्वल्स टू E नॉट माइनस 0.0591 by n log Q.
Yeah, here we wrote the equation as c minus mx instead of mx plus c, so that we can compare it with the corresponding Nernst equation for simplicity basically. So there's no need to be confused regarding that. So yeah.
तो यहाँ से हम सीधा कंपैरिजन कर सकते हैं y इसमें c और m x. यहाँ से हम सिंपल कंपैरिजन करेंगे. हम इसमें अभी कुछ खास नहीं कर रहे अब तक. इस क्वेश्चन का नेक्स्ट पार्ट अब देखेंगे. अब हमें ई सेल निकालना है, तो अगर हमें ई नॉट पता हो और क्यू तो की कंसंट्रेशन तो क्वेश्चन में गिवन है ही, तो हम क्यू तो इन वैल्यूज से निकाल सकते हैं.
Yeah, we are given the values of the ionic concentration, so we can find out Q.
So अगर ई नॉट की वैल्यू हमें पता होगी तो हम ई सेल निकाल सकते हैं और हमारा क्वेश्चन वहीं तक रहेगा.
Right.
अब हम जब इस इक्वेशन ऑफ लाइन से देख सकते हैं कि C इज इक्वल्स टू ई नॉट and intercept is the value of intercept is given as 1.10 volt.
Yeah.
Hence it is equals to 1.10 volt.
Yeah.
अब हम E से लिख सकते हैं 1.10 माइनस 0.0591 बाय N. N की वैल्यू हम सीधा रिएक्शन से निकाल सकते हैं. यहाँ पे Cu की ऑक्सीडेशन स्टेट 2 है, यहाँ पे Cu की ऑक्सीडेशन स्टेट 0 है. तो इन दोनों में डिफरेंस 2 का है. हेंस द वैल्यू ऑफ N फैक्टर दैट इज N इज 2.
Right.
Log of Q. Now Q is Zn2 plus by Cu2 plus.
Yeah.
The value of Zn2 plus, value of concentration of Zn2 plus and Cu2 plus are given.
Yeah.
Hence, we can write concentration of Zn2 plus by concentration of Cu2 plus equals to 0.1 by 0.01, and this is equals to 10.
Yeah. So this becomes log 10.
So it's 1.10 minus 0.0591 by 2. Log of 10. Remember, this is the log on the base 10.
Yeah.
Hence, log 10 on the base 10 is equals to 1.
1. Yeah.
So we can write this as 0.01 minus 0.0591 by 2. And from here, we can get the value of E cell as 1.0705 volt.
Right.
So this is our final answer.
Yeah. So pretty straightforward comparison between the graph given and the Nernst equation, and we can pretty easily arrive at the answer.